Hello and welcome to your Python review for the Q3 exam. All right. So pretty much the entire focus is going to be on coding with sound. All right. All things related to sound. So getting values, changing values, and then just everything we learned about sound in general. So we've got like the amplitude, which is the height of a sound wave, and it affects the volume. And then we have the frequency of the sound wave, which is like the cycles per second, and that affects the pitch. So kind of all that sort of general stuff that we learned is all like fair game when it comes to what you could see on this exam. All right, so let's take a couple of questions here. Some are going to be analyzing code, some are going to be writing code, but they're all similar to the type of things you could see on the test. So for the sound below, mark the changes that will occur to it as a result of executing the following Python commands. All right, so set sample value at sound 0, 3. So again, this is the sound that you're actually acting on. This is the index that you're choosing, and this is the new value that you're giving to it. All right. So important thing to remember is that when you have a sound file, the very first value is at index 0, and then they go up from there. So this one is saying change the value at index 0 to a 3. So it would change this 5 to a 3. All right. Then it says V equals get sample value at sound 2. So that means we're putting a negative 300 into the letter V, because negative 300 is at index 2. Set sample value at 4 to the value in V. Well, we just said that V has a negative 300 in it. 4 is right here. It was previously 0. So now we're changing that to negative 300. And then the last one says set sample value at sound, get length of sound minus 1. So the length of sound is 8, but there is no index 8 because we started at 0. But 8 minus 1 is going to give us 7, or basically turn the last value to 50. All right, so this 120 would go to 50. All right, so that's an example of just kind of analyzing the code and being able to understand how it changes and impacts the different values. And the main thing that's going to trip you up is if you accidentally think this is index 1. It is not. We start at 0 the same way we did for our picture files. Right? And as long as you remember that, the rest of it's pretty straightforward, as long as you know how set sample value and get sample value work. All right, for the two sounds below, mark the changes that will occur to each of them as a result of executing the following Python command. All right, so do you know how the copy command works? Do you know which each of these parameters are and kind of how they relate to each other? All right, so the first part of the copy is our source. That's the file that we're going to be copying. The second one is our target. That's where we're going to copy it into. And then the third piece is the index. It's where we're going to start copying. So this is saying copy sound 2 into sound 1, starting at this index right here. All right. Now this index is get length of sound 1 divided by 2. So let's just put the index numbers on each of these so that we don't make a silly mistake. 9, 10, 11, 0, 1, 2. All right, so these indexes go from 0 to 11, which means the length is 12. 12 divided by 2 equals 6. So we're going to start copying at element 6, and we're going to copy all of sound 2 over. So that means we're starting right here at element 6, the 7 is going to become the 3, the 12 is going to become the 2, and the 10 is going to become the 1. All right. But you should kind of understand how the copy command works, the role of each of these parameters and pieces, and then how it all fits together to modify an actual file. All right, for the 2 sounds below, mark the changes that will occur to them as a result of executing the following Python commands. All right, so this is, do you know how to use clip? All right, so again, this is where you're going to, this is your source. This is where you're going to start. And for this one, I'm going to say stop -1, just because you don't actually go up to that number. Just like when we do a for loop and we have our index, you always stop short of that last number. It works the same way in clip. So whatever this number ends up being, we stop before we get to that number. We don't actually go to that number. You can think of it as like a less than versus a less than or equal to. But I'm just going to write stop -1 just to make sure that that's clear. All right. So again, I'm going to put in my index numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. All right. So the first thing is we use the clip function that creates a new sound object called W. All right. And W is going to clip something from sound 1. It's going to start at 0. It's going to stop at get length of sound divided by 4. So for us, this is 12 divided by 4, or 3. So again, it's 0, 3, but we only get 0, 1, and 2. So that means at index 0, we're going to have a 5. At index 1, we're going to have an 80. And at index 2, we're going to have a -30. So it just takes this part of sound 1, it clips it, and then it creates a new sound object W that has 5, 80, and -30 in its first 3 indexes. All right. But again, main thing here is, even though, yes, this equals 3, make sure you're not actually taking the number at index 3. You're stopping before you get to the 3, which is the way all of our loops have kind of worked this year, but it's still an easy place to make a mistake if you're not paying attention to it. Right? Now that we have this new sound clip W, we're going to use a copy. So again, copy just as before. This is our source. This is our target. And this is our index. So that's where we're going to start copying. So we're going to start copying at index 6. We're going to copy in this W that we just made. So the 8 is going to become a 5. The 1 is going to become an 80. And the -5 is going to become a -30. All right. So again, just understanding clip, understanding copy, understanding these parameters and how they actually interact with and take information from and use on a sound file. All stuff that you need to be comfortable with kind of going into the exam. All right, let's take a look back. Examine the function below. Note that some of the variable names in the function are intentionally unhelpful. I figure, why be helpful? All right, so def alter sound, X, Fred equals make empty sound, get length of sound. Why not Fred? It seems like a good enough name. For sample index in range 0 to get length of sound, value equals get sample value at. If value is less than 0, value equals 0. Set sample value at Fred, sample index, value times X, return Fred. All right, so let's figure out what this is actually going to do. And then we're going to fill in Fred here to see how that all plays out. So it says, consider running this function with the input sound and 2 for x. Fill in the sample values that will be in the new sound Fred when the function is done running. All right. So Fred starts off as empty. So when you make an empty sound, everything initially gets a 0 in it. All right. And you don't actually have to write in these zeros, but because we're going to be changing them all. But technically, when you make an empty sound, everything is just set to 0. All right. Now I'm going to put in my sample indexes. Now, let's see what this loop is actually doing. All right, so for sample index in range to get length of sound. So basically, we're going to be going from 0 through 7. Value equals get sample value at sound sample index. So we're going to retrieve these sample values one at a time. If the value is less than 0, we're going to set it to 0. We're going to set value to 0. I'm sorry. We're going to set value to 0. And then we're going to set sample value at where we're always going to be doing value times x. And for this problem, our x is going to be 2. Right? So when we take the first number, it's a 5. 5 is not less than 0, so we don't do this. And then we just set Fred to 5 times 2, so it goes from the 0 to the 10. All right? Then we loop back up, and we do 80. 80 is not less than 0, so we just do 80 times 2, and this is 160. Right? Then we loop back up. -3 is less than 0, so we set value to 0. 0 times 2 is still going to be 2. I'm sorry, 0 times 2 is still going to be 0, so this one is going to be set to 0. All right? Technically, it is 0, but then we set it to 0. So again, you don't need this level of detail, but technically that's what's happening. -15, again, less than 0, so value is going to be set to 0. We're going to set it. 2 times 0 is still 0. There we are. All right. The next one is 0. It's not less than 0, but it's going to be 0 anyways. So 0 times 2, still 0. All right. Then we get to -6. All right. 0 times 2 is still going to be 0. We get to 7. That one's positive. So it's going to stay what it is, but then we multiply it by 2, and we get a 14 here. And then the same thing with 120. All right, so this is going to become 240. So long story short, if it's a positive number, we're doubling it. If it's a negative number, it's staying at 0. All right, and the reason we're doubling it is because the problem told us it was 2 for x. You know, if they had told us it was 3 for x, we would have tripled it. If they had told us it was 4 for x, we would have quadrupled it. If they told us it is 0.5 for x, we would have cut it in half. X is a parameter, so we can either make it louder or softer. And then it's just when it's positive, we do that transformation. When it's negative, it just ends up being 0. All right. And again, you didn't really need to start with these zeros the way I did. I just wanted to, emphasize that when you make an empty sound, technically everything is 0 at the start. Just writing these numbers in would have been fine. Like I don't need to see the zeros to get full credit. All right, write 3 lines of Python test code below that will read in the sound stored in the file preamble.wave, run the function alter sound on it using 2, and then write the results to an output called alter wave. So this is what you've been doing all quarter long. It would just be something like, S equals make sound using the file preamble.wave. Then we're going to call the function. All right, now this function's returning a value. So we've got to set something up to receive that value. So I'm going to say new sound equals alter sound. And I'm going to send it S, the sound that I just made. and I'm going to give it the value of 2 because that's what the problem specified. But again, this will return a sound object that then gets saved inside of new sound. And then last but not least, I can write sound 2, and I'm writing the new sound object that I created to altered dot wave. All right, so you've written this code probably 100 times already this quarter, but you should be aware of it. You should be able to produce it on an exam. So make sure that that's in your head. All right, 3 more where we're going to start writing some code and fixing some code. Complete the function below that takes 2 sounds as an input. It should return a new sound consisting of the first 22,050 samples of the first sound and the last 22,050 samples of the second sound. Use the sound clip and copy functions. You can assume both sounds contain more than 22,050. Right, so you don't have to worry about kind of running out of room here. All right, so there's our function name, def first last, sound 1 comma sound 2. And then it says add 2 additional lines of code that will call first last and then write the resulting sound to a file called output.wave. So again, kind of talking about what we just did there. All right, so we're going to write the function here, and then we're going to write our test code down here. Now the function, I'm actually going to write on the back here so that I have a little more room for it. So I'm going to do def first last, and the parameters are sound 1 and sound 2. Okay. So I want the first, basically second of the first clip, and I want the last second of the second clip. Right? So the first one's pretty easy. We just say, okay, I'm going to make a sound object called first, and first is going to equal clip, and I'm going to be clipping sound 1. I'm going to start my clip at 0 because that's at the beginning, and I'm going to go to 22,050 because that's what the problem specified. All right, so that would be the beginning. That's the first second. All right, so this is the first second of the clip. Now we want to get the last second of the clip, and this one's a little trickier, but basically we have to work backwards. All right, so we're going to be clipping it from sound 2. Now, if we want to work backwards, we're going to start at the end and then slide back 22,050. So the end is get length of sound 2, but then we're going to slide it back 22,050 by subtracting that. All right, and then we're going to end it. So I ran out of room, but just pretend this is all on the same line there. We're going to end it at the end of the clip. So we're starting at the end minus 22,050, but then we're just going to the end, which would be get length of sound 2. All right, so closing the parenthesis on my get length, and then closing my parenthesis on the clip function. All right, but this is effectively giving me the last second. All right, so now I have a sound object that has the first second from S1, and I have a sound object that has the last second from sound 2. Now I basically want to put those together into a single file, which is what you've been doing inside of your sound collage. All right, so let me just start with, I'll say like new sound equals make empty sound. Now in this one, we could just say make empty sound of 44,100 because we're taking a second from this, we're taking a second from this, but I'm going to do it kind of the traditional way that we've been doing it, which is using the get lengths. So get length of first plus get length of second. All right, that parentheses for the get length, that parentheses for the make empty sound. So now I have an empty sound. From there, I can say copy first into my new sound and start at 0. So it starts at the very beginning. And then I can copy last into new sound. But instead of starting at 0, I could just type in 22,050. But again, I'm going to be a little more sophisticated about it and say get length of first. So I'm basically starting the second one where the first one ends. All right, and then parenthesis to close my copy. All right, so now I've made an empty sound. I've copied in the first second. I've copied in the last second. So all I have to do now is return new sound. All right, so that's my function right there that would take the first second from one clip, take the last second from another clip, and then make a new clip that has those two combined together. All right, now if I go back to the front here, it said add 2 additional lines of test code to actually make this run. So here I've got, S1 equals make sound, S2 equals make sound. I could then say, S3 equals first last. All right, where I send it S1 and S2. First last is going to return a value. That value is going to be stored in S3. And now that I have S3, I could say write sound 2. I'm writing S3, and I'm writing it to output dot wave because that's what the problem said to do. All right, but again, this part should be pretty familiar at this point. You've been doing it again and again and again and again and again and again. All right, number 6. Complete the function below that takes as input a sound and sets the middle 5,000 samples to zeros, thus creating about a quarter second of silence in the middle of the sound. You can assume the sound contains more than 5,000 samples. Note that this function modifies the input sound. It does not create or return a new sound. All right, so we're going to write the function again on the back, and then we'll come back to this page to write the additional code that's required to test it and make sure that it works. All right, so this one is called add silence. So def add silence. And it has one parameter that we've named sound. And then let me get my colon there. Okay, so tricky thing about this one is just how do we get the middle 5,000 samples? Well, we're going to start by finding the middle. So I'm going to make a variable called middle. Well, I'll just call it mid. I'm lazy. And say mid equals get length of sound divide by 2. All right, so that gets me the middle of the sound, the exact middle. Now, if that gets me the exact middle, let's just pretend this is a song, I just found this right here. To get the middle 5,000, I have to go 2,500 above, and I have to go 2,500 below, all right? Because this mid is the exact middle. So I'm going to go 2,500 up, 2,500 down, and that will give me the middle 5,000. So I can set up my loop for index in range. And the range that I'm going to do is mid minus 2,500 to mid plus 2,500. Right, and my colon. Now, once I'm inside of that, I'm pretty much just setting everything to 0. So I don't even need to I don't need to do like a get sample value at, because I'm not like manipulating it. I'm not, multiplying it by anything. I'm just setting everything to 0. So I can just say, hey, set sample value at sound, comma, index. So changing the sound object at the index being generated by my loop. And that's the value that I'm setting it to is 0. Okay. And on this one, I don't need to, I'm not returning anything. I'm just modifying the sound. Like here, like I created a new sound and then I had to return that. Here, I'm just taking in the sound and I'm directly modifying the sound. So there's nothing to return. All right. So going back to the front to write our test code here, we've got my sound equals make sound preamble.wave. Then we just have to call our function that we just wrote, which was add silence. And we're sending it my sound. Now this function is directly modifying my sound. So when I want to write it to a file, I'm going to write sound2. And again, I'm just using my sound again because my function directly changed that. And again, it wants it to go to output dot wave. All right, so that would be kind of the sample test code for that one. All right, one more, and then we'll wrap it up. Consider the following code. It is supposed to take a sound and return a count of the number of samples in a sound that have the value 0, right? But it doesn't work as currently written, right? If the function were working correctly, it would be used as follows to count the number of samples that are 0 in the sound preamble.wave. So s equals make sound. We would send that sound to the function. It would return a count. We'd save that count in C, and then print it out. Right. So as is, this one has a whole bunch of problems. So first we have to identify the problems, and then we have to fix the problems. All right. So I'm going to identify them on this front here, and then I'll write the full version on the back. All right. So right here is the first one, and we are missing a colon. All right. So we've all done that at some point, but you're missing the colon there. For index in range, 0 to get length of sound. All right. We've got our parentheses, we've got our colon. That line is totally fine. All right. Value equals get sample value at sound index. Okay. Still fine there. If value equals 1. All right. So here's another problem. All right. Instead of 1 equal sign, we want to use a double equal sign. And then we have this count plus 1. All right. So if I do count plus 1, that's great, but it doesn't save it anywhere. So this really needs to be count equals count plus 1. Now, there's one more issue here that we haven't really addressed yet. So see if you can figure out what that is, and then pause the video and then like unpause it and we'll actually talk about it. All right. So the problem is that, yes, we're doing count plus one here, count equals count plus one. That's great. We never actually created an initialized count. So up here, we'd probably want to create count and say, hey, count is starting off at 0. All right. We don't want to just start here with count equals count plus one. Let's make count, set it to 0, and then count up from there. All right. So those are basically the 4 corrections that you would want to make. And then let me just write kind of the full version on the back here. So def count 0, it takes in a sound, and then we're adding that colon that was missing before. We're going to create our variable that we're using to keep track, and we're going to set it to 0. All right. Oh, there's one other mistake that I didn't do yet. All right. The other mistake is this is supposed to return the value. We didn't actually return the value. So I'm also going to need a return statement here. All right. I would have got that when we were actually writing out the function, but I forgot to mention it here. All right. So we've also got a return count. Otherwise, it's not going to send back the answer that we need. All right. So def count equals 0 for index in range 0 to get length of sound. All right, make sure you got your colon there. Then we're going to do if. Oh, no, sorry, forgot. Skipping a step. Value equals get sample value at. All right, and we're getting it from the sound object, and we're using the index from the for loop. Then we have our if statement. If value double equals 0, make sure you got your colon. Then we're going to make count get 1 bigger. So count equals count plus 1. And then last but not least, we want to return count. But when you're writing this, make sure that the return is not inside of the if. Make sure that it's not inside of the for. It should be at the same indent level as your count equals 0 and the start of your for loop, so that it doesn't return anything until the loop has been allowed to finish. All right, so all of this is indented for the function. This is indented for the for loop. This is indented even further for the if statement. All right, but that would then go through the entire sound, check to see which values are 0, and just keep a tally as it's working through. Okay, so hopefully that was helpful. All right, so again, being able to analyze code and understand how it's changing individual values, being able to read through a function and understand a loop and kind of what's happening inside of the loop, knowing the different commands to kind of test and output stuff, and then being able to write sort of, simple sound programs that make different modifications, that use clip and copy, that set up loops and get and set sample values. All of that stuff is sort of fair game on the exam. All right. So if I were you, on your study sheet, I'd make sure that I had examples of like clip and copy. I'd make sure I had examples of make empty sound. I'd make sure I had an example of a loop where you're getting sample values, where you're setting sample values, where you're creating different indexes, if you need to start at the middle, if you need to start at the beginning, if you need to stop at a certain point, but just how all those different types of manipulations work. Okay. Let me know if you have any questions. Otherwise, best of luck. Have a good day. Bye.